I'm very pleased to welcome Professor Paul Klint, which is a research fellow at CWI in Amsterdam and a full professor in software engineering at University of Amsterdam, and where you lead the master's program in software engineering. So Professor Klint is extremely well known in our community. I'm not going to read your whole CV, and I give you the floor for your presentation.
Okay, thank you, Olivier. Well, it's my pleasure to be here and to be able to talk about some negative experiences and about some positive experiences in creating spin-off companies. But since we are talking business, what is the first step when you're starting a business? You have to take care of the legal issues. Okay, so step one here, I present you the contract that I want to apply today, and I give you a minute to read it. Okay. Can you all agree to this contract? Others are reading. It's going to be a very empty room otherwise. You think this is a trick question, it isn't. Okay, well, I think the minute is gone by. Who can agree to this contract? Okay, a few people. So for those who didn't recognize, this is just the MIT license modified from software to presentations. And now there are the following possibilities. The people who said yes, welcome. The other people who didn't raise their hand, switch off and don't ever use your mobile phone, since major parts of the software there are according to this agreement. And probably also don't listen. But the nice part of this agreement is I can tell you whatever I want. You are responsible for listening to me. And you can certainly not start a lawsuit if you listen to me and you acted upon that and something bad happened. So that's nice. So now that we are among friends, we can speak freely. And let's discuss the starting point. You are a researcher. Your results may be relevant in practice. And how can you turn them in business? That is the major story. Now, disappointment one, I don't have the definitive answer. But I tried this several times, and I have 24 observations about what can happen to you. And the final point here is, probably most of you attended a course on presentations, giving presentations and making sheets. And there are all these rules like don't put more than 5 bullet points on a sheet. And then you hear this advice and then you say, well, this is clear. But in practice, everybody violates this rule. Well, the same is true here. All these observations will be well, this is obvious, but in practice it will turn out to be not that easy to apply these rules and to remember them. Okay, some background so that you know where I'm coming from. Well, physics and mathematics, working at CWI Research Center, University of Amsterdam. Olivier already mentions this. I have several other affiliations, both in London and here in France, with INRIA, where I lead a joint CWI INRIA team, various other international functions, PhD, master students, etc. I can save you a Google search, so this is what Google is telling about me. H-index 32, most cited articles over 700 times, and so on. So, okay, I'm a research guy, you know. So what is the research method I'm applying in general is to work on real problems, real in the sense that they are also recognizable outside the research community. And then try to import that question, identify theory or extend theory to work on that problem, then demonstrate this in a usable tool, and that, I repeat the remark from Steve before me, that this tool should be usable by others, so not just a throwaway tool, but a usable tool which is well engineered with the user community. That's the kind of results I like. And this should be validated in case studies so that you know that this works in real cases. So there is a whole host of topics I've been working on, most under the label of software engineering, software evolution, software analysis, transformation, visualization, designing languages in general, designing domain-specific languages, metaprogramming, and two more off-topic areas, software IPR. I can tell you nice stories about patents on the inequality operator, on the y-axis, patents on to-do list, and so on and so forth. But that's not the topic today, but that's an interesting area. And the last topic is more recent, and that's about interactive learning. So this all comes together in the Rascal metaprogramming language, which is intended as a one-stop shop for metaprogramming, meaning analyzing programs, transforming them, generating new code, doing data analysis on version histories, visualizing these results, and so on and so forth. So this acts as a reusable lab infrastructure and also as a transfer medium, both to academia and to industry. And we are currently we have gone through all the legal movements of checking our code for license violations, so soon we will be part of Eclipse. So what are we doing? What is this meta-programming in Rascal about? We do work on software analysis, analyzing, for instance, Java programs to spot performance issue in the use of Hibernate, to mention an example, or to calculate maintainability metrics, to transform that code, or to design and implement new domain-specific languages. And I'll mention some domains in a minute. So what are the kind of technical challenges here? That is the whole spectrum from reading in the source code or the metadata to representing this data, computing on this data, and inferring results from this, and finally producing output. So conveniently, we abbreviate this to the easy paradigm, meaning extract, analyze, and synthesize. And that's what we're doing all the time when working on this kind of problems. So here is the overall picture. In general, you start with some unknown system, you extract information from it, you represent this information in some convenient internal way, as relations or graphs or maps, whatever. You repeatedly analyze these data, and when you're happy, you synthesize a result, or if you're unhappy, you go back and repeat these cycles as long as necessary. So this is the basic idea. We provide, and this is of course my favorite sheet I want to spend the remainder of the session on, but I'm not allowed to because of this particular setting. So Rascal is a very nice language with high-level data types, sets, maps, relations, and so on and so forth, built-in grammar definitions, parser generation, constructing trees, traversing trees, generating trees, all kinds of pattern matching and code generation facilities. And last but not least, integration with Java and integration with Eclipse. So we can really extend Eclipse with new features. So, and typical applications are in the refactoring domain, or type checking, or analyzing SVN repositories, or computing general metrics, or, and these are intriguing areas, defining new domains and new domain-specific languages. So currently the Dutch National Forensics Institute is taking into production a DSL we have designed for recovering data from partially damaged files. So that is a DSL, you give it a declarative description of the file formats you're looking for, and then it generates code that searches the disk image for occurrences of certain file types. Accountancy, another domain, gaming, yet another domain, and also there is a growing influence in teaching here. So this is, and this is my favorite picture. So what are we aiming for? Rascal is a one-stop shop where you can find all kinds of cool parsers, or easy way to make type checkers, or you can create modeling gadgets, or you make your own visualizations, customize your IDE, and all that kind of stuff. So this is the basic image. And recently we are also integrating statistics in order to promote statistic programming and analysis of facts extracted from programs' metadata. Okay, enough about my background. Now let's switch to you. So what is a researcher? A researcher is a person who likes new problems and solutions. Okay. A researcher is impressed by clever ideas that solve real problems, clever tools that implement these ideas, good engineering, and clear presentations and publications. And also very important is, if you're a researcher, you want to impress your colleagues. So it's in fact better to give a completely ununderstandable presentation so that everybody in the room thinks, well, I don't understand anything about this, but this must be a very clever guy, right? So your potential customer does not like change. He is not impressed at all by how clever you are or how clever your solution works internally. He cares about how cost-effective the solution is, and whether it is stable, and whether it is fit for his or her organization. So these are completely different concerns. So, for instance, personally, and you can see this from my background, I think it is an extremely good idea to have automatic program transformation tools. They are guaranteed to function properly. There may be proofs of their correct behavior. They are extremely efficient. However, in practice, it turns out that many companies prefer it, that over 100 trainees with not that much experience by hand change the code of the company, and then they can test it. And why is this? Because they know this process. They don't like change, and even if your tool is by far superior, the company is not going to use it, since they will prefer to follow the proven track. And that's extremely unfortunate and very, very you can become very angry about this, but this is just the case. So there are a number of observations here. Researchers and commercial customers have different value systems. Extremely important to be aware of this. Some aspect of this, researchers like open source, and that the idea of open source need not be compatible with starting a spin-off company. So there are all kinds of hybrid solutions for this, but you have to be aware that your key developer is also really an open source person, and it will be very hard to convince this person to move to a non-open source setting. Important. So another formulation of the same observation is, you shouldn't show how smart you are, but you should show how useful you are. That's what your customers want to hear. And finally, but probably this should have been the first one, create a business network. If you want to transfer your research to companies, you need to know people in business. You need to create a network of people who are potential commercial directors or marketeers for your company. So create your network and extend it not only in the academia, but also in business circles. So there is a Dutch proverb, there doesn't seem to be a English equivalent. Een ezel stoot zich in het gemeen niet 2 keer aan dezelfde steen. So the translation is, usually a donkey doesn't triple twice over the same stone. So the story here is, let's try to be a donkey and let's try to learn from experience. So I have 3 stories to tell you about 3 different efforts to create a company. FirstResult in the period 95 to 2005, Tool Engineering in 1989, and from 2001 to present the Software Improvement Group. And so let's try to extract lessons and observations from these efforts. So FirstResult is the first project. It was based on a number of Masters of Science theses. And the objective was, what sounds very obvious today, make a drawing of business process and automatically generate code from this. Sounds familiar, right? So in fact, this is model-driven engineering avant la lettre, so to speak. And it used our own rewriting engine, ASF plus SDF, for code generation. And this was a highly successful operation, in the sense that the technology was there, it worked fine in every pilot study requested by companies. It worked, it just worked. So fantastic. This is the basis for a big success. Unfortunately, this approach is mainstream now, but it was a kind of futurology in '97. So customers, they saw the results, but they could not believe that this was possible. How come that you have spent years of development on your code, then these guys come along, they make a drawing, they push a button, and then code with similar functionality comes out. This cannot be true. Yes, we see that your pilot works, but we cannot believe that this works. So, and another observation was that programmers found this extremely threatening. They thought, we have a job now, but if these guys become successful, we are out of our job. So we don't like this. So effectively in 2005, this company went into sleep mode just for lack of income. That was unfortunate. There are a number of observations. One, already mentioned today, right timing, the introduction of technology is critical. And if you're too early, which was the case here, and when you're too late, it is wrong and you're not going to make it. Another issue, of which, to be honest, I was not that much aware before I saw how this worked in practice, is you have to be very much aware of the psychological and social barriers for acceptance of your technology. And that's at all levels of a company. So you have to convince the decision makers in a company, the boardroom, that your proposal is useful for their organization, meaning it saves them money. I mean, they don't care about how it works. They don't care, probably not that much, how effective your solution is. But if it saves money, well, then you have a convincing case. So that's one side of the coin. The other side of the coin, you have to convince the users in the organization of your technology. And there you have to, you need a completely different story. Those users have to be sure of the technical quality of your tool and your solution. And that may be nice, but then on the negative side, it may be also endangering those. You have to convince them that this may be not as sharp and threatening as they think initially. So, next project, next company, Tool Engineering. So I'm a strong believer in automatic transformation, automatic program transformation. So Tool Engineering was about providing automatic program transformation services. Unfortunately, at that time, our own technology was not yet ready for prime time. So the solution was to take a license on existing technology. In this case, software refinery, which was a product, a software transformation technology from reasoning systems. And that was great technology. We tried to apply this, but the market did not understand what we wanted. And after a short time, we sold the company to Ordina, which is a Dutch software company, but they didn't know actually what to do with it either, so it was killed soon after. So this was a short-lived failure as well. So one observation, extremely obvious, but not so easy to verify, is be sure that there is a market for your offering. But how do you verify this? Another observation is, as a researcher, you like complex technology, but customers don't understand this, so there is a major gap. This means that you have to try to learn the language, to speak the language of your customers, and also to listen to them, since they may have the best ideas for new products or new services. I mean, as a researcher, you tend to think from the center of your own universe. But it may be a slight chance that these customers encounter some real problems that are relevant as well, and are in particular relevant from the perspective of starting a commercial activity. Okay, let's move on to company number 3, the Software Improvement Group. So this was a project that started with a government-funded cooperation project, which was the Resolver project, which ran in the period 96 to 98. And one of the partners was ABN AMRO Banking Company, another known internationally, another one was Pink Rocade, which was a Dutch software company. And the main topics of this project were to assure year 2000 compliance. It was in that era, you know. Thinking about euro conversion and doing research about migrating existing COBOL code to object-oriented code. Those were the main topics. Sounds a bit old-fashioned by now, but that were not so easy problems, and actually still are not so easy problems. So, some observations. It took us, although we were cooperating in the same project, it took us 3 years to get access to the source code of the bank for us to analyze. So 3 years in the project. That's not a very short time. Another thing was, this research cooperation was about year 2000 compliance, but we were not allowed to look into the year 2000 factories that the bank was running, since they were so scared about disturbing a running process. So, which is a bit of a missed opportunity in the sense that maybe we could have had some useful input. But since most things went well, probably our input was not necessary anyway. So what were the results of this project? 2 major results. A really working COBOL transformation tool, and DocGen, which is a documentation generator for COBOL. Okay, so as I will repeat this, customers don't understand software transformations. That's too hard. Customers don't like it when you change their source code. So this big pile, I mean, we are talking about 50 million lines of code, so that's not a small piece of code. But they don't like it if you touch this in any way where you change the code itself. But what they do like is when you add new information to this code. So if you create new insights about this code without touching the code itself, so that remains running, that is okay. That is added value. So that is what we did with DocGen, which is can be briefly explained as follows. We started with the system store sources, and created an automatic fact extractor dedicated for COBOL, which by now has indeed, or a long time ago, processed all these 50 million lines of code they have. There is also an option on the right-hand side to manually extract facts and to enrich the extracted information. This all ends up in a repository, and the information in the repository is formatted into HTML pages. And yes, here is a screenshot of Netscape Navigator. So it's quite dated, and it is in Dutch, which is also very important, since probably the same is true here in France. You have to speak the language of your customer, and this has to be taken literally. So what you see here is our flow charts of applications automatically extracted from the code, all kinds of aspects of the entities being manipulated by the code, the databases being manipulated, extracts of the commands in the code, so that you have an index on the code to find where you are creating an account, for instance, so that you can easily navigate the code. So that was the product which was one of the research results. So then we thought, this is working quite well. So actually, the software transformation part was not working at all. So they didn't like this. But this adding new information, they really did like this. So in around 98, we started about thinking to create a company. ABN AMRO was our launching company, and they took a 3-year contract on DocGen services. So for 3 years we could provide them with up-to-date information about their source code. And well, initially we started in the CWI offices, but soon we moved to a business building on campus. And then when you're creating such a company, there are many hard questions. So I think a crucial question is, are you creating a product or a service? This is an essential difference, since it has a major impact on the investment model. So there is much more to be said about this. This is a crucial element. Another crucial question is about pricing. So, for instance, if you are, this is like the telco providers who provide all these ununderstandable schemes, how much you have to pay monthly. And actually everybody likes it when there is a fixed amount, and everybody hates it when there is no upper limit and you cannot predict how much you pay. But when you're thinking about this, then you think, okay, they have 50 million lines of code. If we charge 1 cent per for every line we process, and we do it every month, then we are going to be very rich very soon. That's a nice perspective, and you can just doing the arithmetic, you can become very rich very soon. However, customers don't like this. Customers like to have a fixed fee, so you have to come up with a model where there is a fixed monthly fee, and they can predict how much it will cost them to do the processing. Well, another challenging question is, how large is this market? Is this offering just interesting for this single organization, or is it scalable? Are there more organizations interested in this? So that's not that easy if you are very early in the game. Another question is, who are going to be the shareholders, and what is going to be the size of their share? Well, in confidence, I can tell you, I have made quite a number of spreadsheets trying to come up with rational ways to explain what was the size of each person's contribution and translate this into a percentage. Well, this fight over fight. So the final solution was equally divide the shares, and that's nobody can defeat that scheme in a way. At least that was the case in our example. And final question, it already came up: how to protect your ideas. So there is copyright, there are patents, and there is secrecy. And in many cases, secrecy is a very good way to protect your key IDs. So, a bit more about SIG. So, what is SIG doing? We translate detailed technical findings about software-intensive systems into actionable information for top management. So the brief version of this is from bid to boardroom. So they do technical analysis and translate this technical analysis into conclusions that can be understood by top-level managers. So today there are a range of services provided by the Software Improvement Group. And I say services, and I mentioned this distinction between product and service. We decided that we are not going for a product company, but we are going for a services company. And one reason for this, why this is a good idea, or at least we thought this is a good idea, then you're not dependent on external investors. If you're starting a services company, you can start small and you can earn money and you can finance your own development and you can organically grow without a need for external investors. This applies when you're choosing for this model. Of course, when you're choosing for a major product development, you need big money to develop the project, to market it, to build the support organization, etc., etc. So building a product company is much, 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 much harder than building a services company. That's one of the things I at least learned. So there are a number of offerings, all having to do with risk estimation of projects, risk estimation of software projects, monitoring services for monitoring the quality of a software system. There is a product certification service, I'll come to that in a minute, and there are all kinds of due diligence services. So this all has to do with inspecting the source code and creating different forms of assessment about the technical risk or the managerial risk of a certain software portfolio. So there are some recent extensions. So SIG is also moving into the domain of green IT. So they are now starting to provide a service to monitor the energy consumption of IT systems. There is a service about reviewing changes to spreadsheets. There are interesting websites about the loss companies make due to the errors in formula in spreadsheets. This is incredible. And some sort of monitoring of your spreadsheets can save an enormous amount of money. So that's an interesting new service. And finally, whole software portfolios are being monitored. So how does this work? First, there is an intake phase where a new project, a new customer comes in. Then the risks of the project are estimated. A plan for monitoring the risk is formulated. And at that moment, there is an opt-out opportunity for the customer who can say, well, no, this is not what I wanted, or this is too expensive, or whatever. But if the customer goes on, then there is a weekly or monthly monitoring of the quality of your software. And if there are deviations, then SIG reports on this. So, of course, then customers try to include their favorite Sudoku solver in their code in order to discover whether they are really looking at the code. And yes, we found this Sudoku solver as an extension of the source code. So it really didn't belong there. So, from risk to control to monitoring, that's in fact the whole process. And this is a kind of cooperative process of finding the risks and monitoring the risks. And then at the end, there can be a real certificate. SIG has part with the TÜV, which is the German certification organization, in order to award software maintainability certificates, where a number of aspects like analyzability or modifiability, testability, modularity, and reusability are the properties of the system which are being assessed. And this is done by looking at the volume, duplication, unit size, complexity, and another number of factors. So a number of technical metrics of the code are translated in properties of the software system that are relevant for top management. And so essentially there is a cycle between the system producer, which delivers the system source code. This is evaluated by an evaluation body, which is in this case a software improvement group, who write an evaluation report. This is validated by the certification authority, the TÜV in this case, and they hand out a certificate. There was supposed to, well, there was supposed to be a yeah, there is. So this is the kind of certificate. This is not easily readable. So this is the port of Rotterdam, whose software was certified in this way. And there are more and more organizations who have a certificate for their software. So there is a range of customers, and in the Netherlands, big players like Rabobank or KLM, also international players, IKEA, major car companies, major logistic companies. So there are some 100 customers or more even. And so what is essential here? SIG is an independent party. So they are independent of research and of services providers, so they can really make an independent statement about quality. That's one. This association with the TÜV IT, is an interesting link where a small organization acts as an evaluation laboratory for a certification organization. And SIG is actively evolving a research policy. So one example, current example, is there is a cooperation with a professional university in the Netherlands where a green IT lab, a software energy footprint lab was created, where there are actual machines running applications and their measurements about energy consumption of those particular systems are being done. So 20% of the revenue are reinvested in research, so that's neat. An impressive number of master students, PhD students hosted, lot of research cooperations, over 40 publications with a SIG employee as a co-author, that's nice. And, well, cooperations all over the place. Software Improvement Group is a growing business. So this is from 2005 to 2011. The number of employees has doubled in that time, and the turnover is really going up quite well. So we are looking to see how this is going to evolve in the future. So some final observations. I already stressed this distinction between product and service. So a large upfront investment versus a steady stream of income. Be aware of the legal issues. The fact that you are now a business person does not mean that you should spend money. So it is very wise to be very economical, to have not so impressive offices, use not so impressive cars, if any. So be very careful to limit your expenses in the initial phases. It is also very important to know yourself. A good researcher is not necessarily a good business person. So if you're a good researcher, maybe you should partner with a good business person who is much better in transferring your ideas to the market. And final point is, coming back to the title of this presentation, research and spin-off should be considered as completely different games. Research is the game of creating publications. A spin-off is the game of creating revenue. And these are completely different and lead to completely different strategic choices day after day after day. Okay, thank you very much, and I'll love your feedback.
So we have time for questions.
I see someone in the back there. In the back there? Oh.
No question?
Just waving.
Yeah, I start just, but since you mentioned it's not because you're a business person and that you have to spend money. This reminds me of my young years where my father was in the mine companies in the east of France, and they were organizing the transition for closing the mines, and actually they were bringing people who worked in the mines to visit companies that were created in the area, and there was one company which really grew up very good in building heating systems, and when they brought the miners there to apply, and they did visit the factory, and they came back, and quite surprisingly they had no application at all for this specific company. No one wanted to go to this company, so they made a poll and asked the people, why don't you go, why don't you apply to this company? It has a really good vision for the future, and people say, no, we don't want that. This company is going nowhere. And say, why don't you see that? It's because we saw the head of this company, and we saw him coming to the work this morning, and he didn't have a Mercedes. And that's a true story. Now let's go back to more scientific questions. So you do code analysis, and you do it on very big projects, actually. And when listening to your presentation, I was thinking, currently people are making a lot of money with this €1 code that they do on very small Apple applications with mashup that they then push on iPhone or put on Android devices, and they sell these applications for very little money. And these applications, maybe even more than very big projects, they need some analysis too, being it for security or for just improving the energy footprint, as you said. So do you think that your approach, your technology would be well fitted as well for these kind of applications, and maybe deployed at Apple, since Apple is one where you have to submit your code and get it analyzed?
I would say that this depends largely on the kind of technology that is used for creating these applications. The more dynamic the languages are that have been used, the harder it is to do analysis of, for instance, security aspects. So I find it hard to answer this in general. So you have to look at the technical details of the project, whether this is applicable or not. We certainly haven't done it yet. That's for sure.
Hello, I'm Animesh Pathak from INRIA Rockencourt. It was very good to hear stories from you about real-life lessons learned by making the mistakes and doing the right things while making these spin-offs. I think I missed the parts about intellectual property issues. Can you share a little more about incidents you experienced on that front?
Yes, I can. I mean, there are three ways to protect your IPR, being copyright, patent, security. So Coca-Cola works quite well because the recipe is secure. And now copyright you get automatically, so to a certain extent that is an easy way to protect your IPR. And then you have patents, and patents that's a very difficult area. I've done some work in this for the European Commission, studied quite some patents, and for instance encountered the patent about the inequality operator. So there's a patent where the is not equal operator is patented, and when you start reading through the patent database, you discover that there exists a patent on the y-axis. Yes, there is. there is a patent on to-do list. Yes, there is. So, and if you start looking, you become more and more surprised about all these things which are patented. But coming back to your question, if you patenting is a very painful and expensive process. So you really need to have a very compelling reason to go for patents. Yeah, well, look at the current wars in the mobile domain. So, but we can learn from history here. So 100 years ago, there were the wars around the patents for sewing machines. So making clothes. And in a completely similar manner as we see today, all these patent holders were suing each other in larger and larger lawsuits, and that was leading nowhere. And what was the resolution of this? A patent pool in which everybody put his patents and got some licensing fees out of this in order to allow everybody to use the same technology and to move forward. Well, my prediction is this will happen in the mobile domain as well, since the current situation is unusable. Still no real answer to your question, but these are some thoughts about IPR.
Okay. Additional questions? I'm looking, so we don't have questions from online. So then, thank you very much.
Okay, you're welcome.